Hello everyone, welcome to Radiant Minds Academy. In this video, we will provide the solution to these 5 exponential equations given to us. These equations are very close to exam questions for exponential equations. I will guide you through on how to obtain the result of each of these exponential equations, and also I will guide you through on how to check if your answer is correct or if the value you got as your answer satisfies the equation. So if you know you found this helpful, please don't forget to like this video and subscribe to this channel. Now let's dive into the solution of our exponential equations. So let us start with this question. We are given that 3 raised to the power of 2x is equal to 27. So we are asked to obtain the value of x. So we have that 3 raised to the power of 2x is equal to 27. So recall that 3 raised to the power of 3 is equal to 27. So this becomes 3 raised to the power of 2x equal to 3 raised to the power of 3. Now, since we have the basis to be equal, then it is true that the index are also equal. So this becomes 2x equal to 3. So to obtain the value of x, we divide both sides of the equation by 2. So we have that 2 can cancel out 2. So x is equal to 3 divided by 2. So let us check if our equation is correct. Let me get rid of this here. So we have the equation they gave to us is 3 raised to the power of 2x is equal to 27. Now we are back checking. So we have that 3 raised to the power of 2, our value of x is giving us 3 divided by 2, which is equal to 27. So at this point, 2 can cancel out 2, so we'll be left with 3 raised to the power of 3, which is 27. So therefore, this is 27 equal to 27. So thus, S is correct. S is 3 divided by 2. Now, we have it that 3 raised to the power of 2x minus 3 raised to the power of 2x minus 1 is equal to 18. So we're asked to find the value of x. So let's start. So we have that 3 raised to the power of 2x minus 3 raised to the power of 2x minus 1 is equal to 18. Now, from the division law of indices, if I have a squared divided by a raised to the power of 1, this can also be expressed as a raised to the power of 2 minus 1. That means if I have a raised to the power of 2 minus 1, this can also be expressed as a raised to the power of 2 divided by a raised to the power of 1. Now, let us apply this knowledge at this point. So we have it that this becomes 3 raised to the power of 2x minus 3 raised to the power of 2x divided by 3 equal to 18. So this can further be expressed as 3 raised to the power of 2x minus 3 raised to the power of 2x divided by 3 equal to 18. Now at this point, we can factorize the left-hand side. So if we factorize 3 raised to the power of 2x, the equation becomes 3 raised to the power of 2x, open your bracket, 1 minus 1 divided by 3 equal to 18. Now, if we simplify the term inside the bracket, so we have that this becomes 3 raised to the power of 2x, open your bracket, 3 minus 1, all divided by 3. This is equal to 18. So this becomes 3 raised to the power of 2x multiplied by 2 divided by 3 equal to 18. Now we can divide both sides of the equation by 2 divided by 3. So we have that this becomes 3 raised to the power of 2x equal to 18 divided by 2 divided by 3. First, this can be expressed as 3 raised to the power of 2x equal to 18 times 3 divided by 2. So 2 cancel out itself, we have 1. 18 divided by 2, we have 9. So this becomes 3 raised to the power of 2x equal to 9 times 3 is 27. So at this point now, to obtain the value of x, we have to express 27 in base 3. So this becomes 3 raised to the power of 2x equal to 3 raised to the power of 3. Now, since their bases are the same, it is true that their powers are also the same. So therefore, we have that 2x is equal to 3. So if we divide both sides by 2, x is equal to 3 divided by 2 because 2 can cancel out 2. Now, let us check if our result is correct. So we are to check if what is at the left-hand side correspond to what is at the right-hand side. So the equation was 3 raised to the power of 2x minus 3 raised to the power of 2x minus 1 equal to 18. Now we obtain the value of x to be 3 divided by 2. So we have that 3 raised to the power of 2 will all be raised to the power of 3 divided by 2 minus 3 raised to the power of 2. Our x is 3 divided by 2 minus 1 equal to 18. So we want to check if the left-hand side is equal to the right-hand side. So 2 can cancel out 2. We have that 3 raised to the power of 3 minus, here also 2 can cancel out 2. So we'll be left with 3 raised to the power of 3 minus 1 equal to 18. So 3 raised to the power of 3 is 27 minus 3 minus 1 is 2. 2 raised to the power of 3 is 9 equal to 18. So 27 minus 9 is 18. So therefore, our answer is correct. So now, let us consider this indexer equation. So we are given that 3 raised to the power of x plus 2 plus 3 raised to the power of s is equal to 10 divided by 81. So we are asked to find the value of x. So we are given that 3 raised to the power of x plus 2 plus 3 raised to the power of x is equal to 10 divided by 81. So at this point, we can have that this becomes 3 raised to the power of x multiplied by 3 raised to the power of 2 plus 3 raised to the power of x is equal to 10 divided by 81. So on that note, we can factorize 3 raised to the power of x. So the equation becomes 3 raised to the power of x, open up a bracket, 3 squared plus 1 equal to 10 divided by 81. So this simplified to become 3 raised to the power of x. 3 squared is 9. 9 plus 1 is 10. So we have 10 equal to 10 divided by 81. We can divide both sides of the equation by 10. So we have it that 10 can cancel out 10. So we'll be left with 3 raised to the power of x. This is equal to 10 divided by 81 times 10. So 10 can cancel out 10. We are left with 3 raised to the power of x is equal to 1 divided by 81. So we have that 3 raised to the power of x, 1 divided by 81 can be expressed as 81 raised to the power of negative 1. Now we can express 81 in the base of 3. So we have that this becomes 3 raised to the power of x equal to 3 raised to the power of 4 all raised to the power of negative 1. So therefore we have that 3 raised to the power of x is equal to 3 raised to the power of negative 4. Now since the bases are the same as usual, so the powers are the same. So our x is equal to negative 4. We are asked to obtain the value of x, given that 5 raised to the power of x plus 1 plus 5 raised to the power of x is equal to 150. Now let's obtain the solution. The equation given to us is 5 raised to the power of x plus 1 plus 5 raised to the power of x is equal to 150. Now recall that in indices, if we have an expression a raised to the power of b plus c, this is the same thing as a raised to the power of b multiplied by a raised to the power of c. So since we had the same base to be equal, then the powers were added. Now also this can be done at this point. So we have it that this becomes 5 raised to the power of x multiplied by 5 raised to the power of 1, which is 5, plus 5 raised to the power of x equal to 150. At this point, we can factorize 5 raised to the power of x. So we have that 5 raised to the power of x, open up the bracket, 5 plus 1 is equal to 150. And the equation will reduce to 5 raised to the power of x multiplied by 6 equal to 150. So if we divide both sides by 6, the equation becomes 5 raised to the power of x equal to 150 divided by 6, which is equal to 25. So we have it that 5 raised to the power of x is equal to 25. Now we have to express 25 in the base of 5. So we have it that 5 raised to the power of x equal to 5 raised to the power of 2, because 5 squared is 25. So since the bases are the same, the index or the powers also should be the same. So therefore x is equal to 2. Now let us check if we are correct. So the equation given to us initially was 5 raised to the power of x plus 1 plus 5 raised to the power of x is equal to 150. So we had it that 5 raised to the power of x plus 1 plus 5 raised to the power of x is equal to 150. And our product of s is equal to 2. So we have it that 5 raised to the power of 2 plus 1 plus 5 raised to the power of 2 is equal to 150. So since we are checking if it is equal, let's add a question mark here. So we have that the left hand side becomes 5 raised to the power of 3 plus 5 raised to the power of 2 equal to 150. 5 raised to the power of 3 is 125 plus 5 squared is 25 equal to 150. So thus, 125 plus 25 is 150. So therefore, our result is correct. It means that x is equal to 2. If you know you found the video helpful, please don't forget to like this video and also subscribe to this channel. We are asked to obtain the value of x, given that 5 raised to the power of x plus 2 multiplied by 4 raised to the power of x plus 1 is equal to 5. Now, let's dive into it. Now, this is a technical question because we do not have the same base at the left-hand side. So we have to manipulate the left-hand side so that this either we have the same base or we have the same index. So we have it that the question was given 5 raised to the power of x plus 2 multiplied by 4 raised to the power of x plus 1 equal to 5. Now, let us divide the equation by 5. So we divide the right-hand side by 5 and also divide the left-hand side by 5. So 5 can cancel out 5, we have 1. So the equation becomes 5 raised to the power of x plus 2 multiplied by 4 raised to the power of x plus 1, all divided by 5 equal to 1. So at this point, we have it that 5 raised to the power of x plus 2 divided by 5 multiplied by 4 raised to the power of x plus 1 is equal to 1. So recall that in our division rule of indices, if I have a raised to the power of b divided by a raised to the power of c, this is equal to a raised to the power of b minus c. So at this point, we now have that this becomes 5 raised to the power of x plus 2 minus 1, because the highest power of 5 here is 1, multiply by 4 raised to the power of x plus 1 equal to 1. So we have that this becomes 5 raised to the power of x plus 2 minus 1 is plus 1, multiply by 4 raised to the power of x plus 1 equal to 1. Now, at the left-hand side, we have different base but the same power. Now, recall that in indices, if I have a multiplied by b all raised to the power of n, this can also be expressed as a raised to the power of n multiplied by b raised to the power of n. This is known as the product power law. So we can apply this law in this equation. So we have it that 5 times 4 all raised to the power of x plus 1 equal to 1. So 5 times 4 is 20. This becomes 20 raised to the power of x plus 1 equal to 1. So recall that 20 raised to the power of 0 is still equal to 1. So this becomes 20 raised to the power of x plus 1 is equal to 20 raised to the power of 0. Since the bases are the same, then the indices or their powers should be the same. So x plus 1 is equal to 0. So x is equal to negative 1. Now, let's check if our value of x equal to negative 1 satisfies the equation. So the equation given to us was 5 raised to the power of x plus 2 multiply by 4 raised to the power of x plus 1 equal to 5. So since s is negative 1, we have that 5 raised to the power of negative 1 plus 2 multiply by 4 raised to the power of negative 1 plus 1 equal to 5. So we want to check if x equal to 1 satisfies the equation. So minus 1 plus 2 is 5 raised to the power of 1. Minus 1 plus 1 is 0. So 4 raised to the power of 0 is 1. So this is times 1 equal to 5. So therefore, 5 is equal to 5. Thus, s equal to negative 1 is correct. If you know you found the video helpful, please do not forget to like this video and also subscribe to this channel for more maths videos like this. Thank you so much for watching. I will see you in my next video.